This lesson is on predicting nuclear stability. In determining if the nuclide is stable or not, there are some things that must be considered. The neutron to proton ratio, N to Z, and the total mass of the nuclide. The rules for identifying a stable or unstable nuclide. If the nuclide has a mass not greater than 40 and has an N to Z ratio equal 1, the nuclide is deemed stable. Note, a stable nuclide has to have either N or Z be even. The exemptions are 11H and 32HE. Once the mass is greater than 40, then these rules apply. And for masses which is less than or equal to 40, where the N to Z ratio doesn't equal 1, these rules are considered. If the N to Z ratio is greater than 1, and if the mass of the nuclide is over the atomic mass on the periodic table, the nuclide must undergo a beta decay to be deemed stable. If the N to Z ratio is less than 1, and if the mass of the nuclide is under the atomic mass on the periodic table, the nuclide undergoes either a positron emission or electron capture to be deemed stable. If the N to Z ratio is greater than 1, and if Z is greater than 83, the nuclide must undergo an alpha decay. Lastly, if the nuclide has one of these magic numbers in respect to either protons or neutrons in its nuclide, then it is deemed stable. For neutrons, the magic numbers include 2, 8, 20, 28, 50, 82, and 126. For protons, the magic numbers include 2, 8, 20, 28, 50, and 82. Here is a sample problem. Are any of the following nuclides stable? If radioactive, explain why and determine what reaction it must undergo to become a stable nuclide. We have 1810 Ne and 3216S. The answers are as follows. For 1810 Ne, it is a radioactive nuclide because the N to Z ratio is less than 1, so more neutrons are needed to be a stable nuclide. It can do so either by a positron emission or an electron capture. For 3216S, it is a stable nuclide because the N to Z ratio equals 1. Here is practice problem number 1. Look at the following nuclides. Which of the following would you predict to be stable? If not stable, what nuclear reaction must the nuclide undergo to achieve stable status? They are 28O, 5927CO, and 24195AL. Here is practice problem number 2. Use the atomic mass of the element on the periodic table to determine what decay must these radioactive nuclides undergo to be stable. They are 125B, 23492U, and 12757LA. For the main part of this lesson are solutions to practice, review exercises, or problems. Please view only after completing these